Okay, so page 30. Julie is a sales clerk at a bicycle shop. She's paid $12.25 per hour, and she's given commission of 8% on top of that. In 1 week, she worked 30 hours, and her sales were 2,319. What was her gross weekly earning for that week? Okay, so first off, I know that she worked 30 hours at $12.25 per hour. So those two, I just have to simply multiply them. All right, so 12.25 times 30 hours. That will give me my base commission, base salary, which is $367.50. Okay. So then now if I look at this, the 2,319.75, is that mine? No, that's how much she helped the company make. Okay, so because she doesn't own the company, she's only a worker, she gets 8% of that. So 8% of 2,319.75. Oh, so 0.75. So remember back in chapter 1, when we do percentage, 8%, 0.08 of means times, and then times that. So 0.08 times 2,319.75, that's 185.58 in commission. So when you add them all together, add the two. Let's see. You are correct. So your unit dollars, so $553.08. Okay, so that's how much she made for that week. Okay. Why do you think the hourly wage is so low? Sophia?
It depends on her sales more.
Right. All right. So you can see the harder she works to sell you stuff, the more that she can make. Yep, you can. Okay. Number 2. Sam is paid $14 per hour and 6% of her sales. He worked 37.5 hours in 1 week. What would his sales need to be for him to make $733.50? So this one is a little different. Okay? So almost like working backwards. So first off, again, let's figure out the part that we just do directly. $14 per hour, 37.5 hours. So $14 times 37.5. 14 times 37.5. Okay. 525. You can work half an hour at work, especially on shifts. Okay. And then he made this much for the week. Okay. So that means I have to subtract this from this to figure out how much she made just on commission. Okay. So if I subtract these two, 733.5, take away 525, that means if I subtract this from this, that means she made $208.50 in commission. Commission. I think there's 2M, but it's okay. Okay. So if I set it up the same way like this, I'm trying to figure out the percentage, right? I'm trying to figure out, oh, sorry, no. He does make 6%. I know he makes 6%. So 6% of something, just like how we set it up here, 6% of the sale amount would equal 208.50. Okay, so if I do the exact same thing, then that means 0.06x equals this. So to solve it, I would divide. So when I use this, divided by 0.06, I can get the amount of sales. So which gives me $3,475 worth of sales. Okay. Just like the question up here. Julie, you got it?
Yeah.
Well, that was fast. Okay, so Julie had to sell 2,300 worth to make an extra 885. In this case, her percentage is 6%, so she had to sell 3,475 worth to make the extra 208. Okay, so this is a trickier type of question because there's a lot of back and forth and you're working backwards, but that's the logic behind it. Okay. Overtime pay, we talked about it in class on Friday. So 40 hours is the standard. So in this case, she makes $20 per hour. So $20 times 40 regular hours plus, if you do what's the overtime pay then? 30, right? So then for the rest of the 12 hours, you're actually being paid at $30 per hour. So 20 times 40 plus 30 times 12 equals, 1,160. Okay. What about Anna? She didn't work overtime because it's under 40 hours. So all you have to do is simply times it. So 30, 1550 times 36. And that's all you do for this because she didn't work overtime. So $558. Okay, how many of you got all four correct? Okay, good job. Okay, so if you see these type of questions on EQAO, do you think you can do it? Yeah, so these are the type of questions that they will ask because it's more realistic, more real life. You need to know if your employer is paying you correctly or if they're scamming you. Okay, so now that you have income, okay, you made money, what are you going to do with that money? Save it. Where? In your piggy bank? Yes. What's a better option than a piggy bank? A bank, right? So a lot of these places, when they start paying you, they're not gonna pay you cash. Okay? Reason is because if they employer pay you, they can write off some of the taxes for themselves. So they won't pay you cash. They will pay you directly through your bank account. So in bank account, so who has a bank account already? Good.
I got mine on the weekend.
Awesome.
I got my first debit card.
And is it because of math class? Yeah, sure, right. You and if you don't already have one, there you go. You can tell your parents, Mom, we just learned about interest and how important it is to start having a savings account. Let's open one, okay? And you can make my first deposit for me. All right. So, how many of you have a bank account with TD? Okay, RBC, Scotiabank, BMO. Okay. Oh, you have two accounts. Where do you have it? Oh, all right. CIBC. Oh, a lot of you guys have CIBC. Why CIBC?
Got a free backpack from there.
Oh, incentive. That's right. Oh, and it says CIBC on it. All right. So these small incentives, yes, that's great, but what would a bigger incentive be? Interest, right? So interest is basically money. Yes.
Incentive.
What was your incentive?
I open my savings account and then they give me like a 4.9% interest for the first 90 days. So I put $1,000.
Woo!
So I will get a lot back.
Yes. Okay. So, how much did you say they are paying? 4.9%.
I think 4.9% for 90 days.
4.9% for 90 days. Okay. And so you put 1,000. Okay. So keep that in mind. We're gonna learn about the different formulas, and then we'll figure out how much you actually get after the 90 days. Okay. So there's two types of interest. One is called simple interest. One is called compound interest. The formula to calculate interest is different. You can see. Okay. So I, what do you think I stands for? Interest. What took you guys so long? Interest. Okay. P. Principal. Good job. Principal. So like the initial value, how much you're putting in. So for example, in Yancy's example is at $1,000 principal. Principal, not Mr. Rowe. Okay, principal. L-E. How do you remember is principal? Like the guy is your pal. So P-A-L. You want the principal to be your pal. So, and then the principal amount is the L-E. Okay. R, the rate. Right. Right. And it's a percentage. Right. And then T, time. Yeah. Okay. So nice and easy to remember. These ones make sense to me. Now on this side, compound interest. Okay. The A right here. Notice this is a I equal formula. This is a A equal formula. A stands for the amount at the end. So basically, it's the principal plus your interest. Okay. So at the end of the 90 days, when Yanzi goes back to her account and check the balance, that balance at the end would be the A. Okay, principal P is the same thing, stands for principal. The I, what do you think I stands for? Yeah, interest, right? It's a interest rate. So interest rate. But then if you paid attention, you're probably thinking, isn't rate R? Why is this interest rate again? This is interest rate per term. Okay, the per term will come in, we'll explain that in a second. Okay, and then the N right here is also time, but it's the not per year. So simple interest mainly deals with the year. This one is still dealing with different time frame. So you can think of number of payout, number of payment. That's probably the easiest way to distinguish the difference between time and number of payment. Okay. So compounding terms, just to go over some terminology first. So annually means what? Once a year, right? So once a year. Semi-annually means how many times a year? Yep. Half a year or how many times a year? Right, twice a year. So 2 times a year. Okay. Quarterly means how many times a year? 4 times a year. Monthly? 12 times a year. Yeah. Bi-weekly? 26, right? Not 24, 26. Weekly? 52. And daily? 365 days a year. Okay, so keep in mind these numbers. You will use these numbers very often, especially when we calculate compound interest. Okay, so now that we have all the definitions, we have all the numbers, let's do examples. We're going to do 4 examples together. Lucy, she invested $3,000 in a savings plan that pays simple interest. That's the keyword. At 3.5% per year for 4 years. So whenever we talk about simple interest, 99% of the time we're talking about an annual interest rate. Okay, so simple interest at 3.5% per year for 4 years. How much will she have at the end of her term? Okay, so which formula do you think we should use? Simple interest, because it tells you simple interest. And on the test, on the assignment, it will tell you simple interest or compound interest. So I equals P times R times T. So principal is how much? What's the rate? 3.5%. Can I change that to a decimal? Good. This is 0.035. Not 0.35. That would be too good. So 0.035. How long? 4 years. Okay, so let's times that. Times 4 years. So $420. So at the end, when I go back to my account, I go to the ATM and I press. Am I gonna see $420 as my balance for him? Right. So remember, the amount at the end is principal plus interest. So 3,000 plus the 420. So that means at the end, my balance would be $3,420. Right. So, how many of you think earning $420 in 4 years is good? How many of you think it's bad? Wow, you guys are so demanding. It's free money, guys. What did you do in that 4 years to earn $420? Okay, so technically you did nothing and you got for 420, which is pretty good actually. But instead, what could you have done? Yeah. No, but with that 3,000, with that 3,000. So instead of just leaving it there for 4 years, stocks, okay. So there are other options. I'm going to go over that too. There are other options that will pay you higher interest or investments that you can make more than that 420. Some people do it, invest in stocks, but what's the bad thing about stocks? Yeah, you could lose it all too. So it's not guaranteed that you make more money. Okay. On the other hand, example 2, Daniel, you have $2,000. All right. And you decided to put it in a savings account that earns 2% compound monthly. How much would you have at the end of 4 years? Okay. So, which formula do you think I should use for number 2? Should I use the simple interest or compound interest formula? Compound. Which word in the example tells you to use the compound? Right. Yes. Okay. So that's how you know which one to do. Okay. So compound interest. That means I'm doing this formula. Okay. Principal. How much is Daniel investing? Daniel, why don't you answer that? How much are you investing? How much money? 2,000. 2,000. Yeah, that's your principal. Okay. 1 plus the I. Okay, as we said, is the interest. So 2% is what as a decimal? Right. But remember right here, we said interest rate per term. So how often is he getting interest? Monthly. Okay, monthly means 12 times a year. So he's actually that 2% is an annual rate. So when we divide it by 12, then we know how much he's getting each month. So yes, it's going to be a very small number, but that is the correct math. So that means each month he's getting 0.0016 percent worth of interest. Okay. When you change these numbers, you do want to take at least 4 decimal place. If you just do 0.0, if you round it to 1 decimal place, it means he's not getting any interest. Okay, so yeah, at least 4 decimal place. Okay, so 0.0016, okay, n is how long are you investing it for? 4 years. Okay, again, n represents not just number of years but number of payments. So in that 4 years, how many times is he going to be paid? If he's paid monthly, yep, 48. So you times it by 12 in this case. So for interest, it's always divide, and the n is always times. So your exponent here is 48. People always miss this step, and put a 4 right here. Okay. So now we can do, if your calculator is like this, where it shows you like exactly what you type, okay, then you can just type this whole thing in. If your calculator is these ones right here, where it won't even turn on, okay, then you have to do BetMath yourself. Right? So let's do BetMath. So 1 plus 0.0016 is, I'm just gonna add a bunch of 6. Press the equal sign, raise it to the exponent 48, press the equal sign again, and then times it by 2,000. And you'll get $2,166.43. Okay. So sounds pretty good, right? 4 years, I made 2,166, right? How much did I actually make? 166. Why am I taking out that 2,000? Right, because that was mine. The bank didn't give me that. So part B, how much interest was earned? So amount equals principal plus interest. So if I subtract the principal, so 2,166.43, take away my original $2,000, that means I made $166.43 in interest. Okay. Is that good money? Bad money? Wow, you really changed from. Okay. Okay. So technically, yes, again, you didn't do anything for 4 years and you made $166. That's not too bad, but it is very little. And in reality, you get even less than that. Okay. So if Daniel wants to earn more interest, what are 2 things he could have done to earn more interest? And this question, you will definitely see it on EQAO every year. Okay, so what's one thing, Nancy? Yeah, increase principal. Increase principal. So put more money in. Yep, that's a good one. What else? Yep.
Wait longer.
Good, longer term. Longer term, so leave the money in the account for longer. Okay, what else? One more.
Or just switch to a bank that has higher rates.
Excellent. So higher interest rate. EQEO love asking that question. It will ask what are like does this action make you more money or make you lose more money and so forth. It's a drag and drop. Every year I see this. Okay. So on the other hand, Jeff. All right. Jeff wants to buy a new car, priced at $33,000. He puts a $4,000 down payment and finance the rest with CIBC at 3.5% compounded monthly for 5 years. How much does he end up paying for the car? Hey. So, which of the two formulas should we use? Compound, because of this word right here. Okay, compound. So I'm going to use A equals P 1 plus I to the n. Okay? What's my principal amount?
4K.
That's my down payment. That's my down payment. So 29,000, right? So what is a down payment? What is a down payment? Anyone know what's a down payment? Sophia?
Like your initial payment, you just pay some and then pay the rest after.
Good. Okay, so down payment is like the initial amount. So Jeff wants to buy this car for $33,000, but I don't have 33,000 to like put in a briefcase and bring to the dealership. I only have 4,000. So I give them 4,000. So now my principal is 33,000. Take away the $4,000, which means my principal, the amount that I have to pay interest on, is only 29,000. So that's my principal. Okay, and the reason why people put a down payment is because they want to lower their principal, to lower the amount that they pay interest on. Okay?
Wait, but if you pay like monthly or yearly, doesn't the dealership charge you?
Well, we're gonna talk about that next. Good. But the very first thing that Jeff could do to pay less interest is to put a down payment down. Okay. So 1 plus I. How do I calculate I again?
I gotta convert it to months.
Yeah, so 0.035, and then what do I do with it? Divided by 12. Okay, is it always 12? Nope. Okay, if it says compounded semi-annually, I would divide by 2. If it says compounded quarterly, I would divide it by 4. So monthly, that's why we divide it by 12. 0.035 divided by 12. 0.002916. Okay. And for the n, how long am how long am I taking to repay?
60 months.
Good. 5 years times 12 months, which means 60 months in total. I'm taking 60 months. All right. Put these into the formula. So 0.002916. Okay, all raised to the exponent 60. Try this on your calculator. A lot of people make this mistake in the calculation. They have everything right, but they don't know how to use their calculator. Okay, try it on your calculator. Okay, I got an amount. All right, try it out.
Like 34,000.
Okay, let's see. What did you guys? I got this.
What?
Exactly?
No.
Okay, if you're off, it means that you didn't take more digits.
I didn't know.
Yeah. So it does make a big difference with the interest rate because this is how much you're getting every month for 60 months. So that little decimal, if you do it 60 times, it will make a difference.
I have to type 660.
Not 60 times, but like do a few six.
Okay.
Yeah. Okay. So for you, you might have just been off by like a couple of pennies, but imagine if he wasn't buying a car, he was buying a house. Those little digits would make a difference. Okay. So so that means he got the car for 34,500, what was it? $537.34 to be exact. All right. So that means he only paid an extra 1,000-ish, 1,500 in interest. Is that right? Does that sound good? He financed the car for 5 years and he only had to pay 1,500 in interest. Does that sound right? Okay. The $1,000,000 question. Did he really only pay 34,000?
That's 4.6%.
Hey, where my big brains? I know it's a Monday morning, but my big brains. How much did he really end up paying for the car? Yeah, Sophia?
38,537.34.
Right. Yes. Don't forget the 4,000 that you paid up front. So yes, you do have to add back that 4,000 that was yours at the beginning. So that means in total you paid 38,537.34 for the car. Right? So that was the final cost of the car. So how much extra did you pay? The car was 33,000. Yeah, so 5,500. Woo. Okay. So how many of you think that's like a ripoff? Paying an extra 5,500. Okay. But what can you do? It's either you pay that, or you don't get a car. And that's how the logic works in real life. You don't have the 33,000 and you want a car, then pay interest. You want to live in a $1,000,000 home, but you don't have $1,000,000, you pay a whole lot of interest for a $1,000,000 home versus a $33,000 car. That's a lot more times. So people do pay like $5,000 worth of just interest a year, or $50,000 worth of interest a year. Like there are people who live in uh like $3 million home, and not even talking about mortgage. We're talking about like the property tax. Their property tax on a $3 million home is like $25,000. So you can afford a Toyota every year. just just paying tax. Yeah, that's sad. Okay, but if you don't have that money, and you have to pay interest. So what are three things that we could do to lower our overall cost then? Yep.
Put more down payment.
Put down more down payment. Okay, so lower principal with a down payment. Okay, what else? Max?
Shorter term.
Shorter term, right? So instead of taking 5 years to repay, maybe you can repay back in 2 years, 3 years. Okay. What else? The last one.
Get a cheaper car.
Okay, yeah, that would be part of lowering the principal. Lower interest rate. That's right. So go to a bank that offers you, like let's say CIBC is giving you 3.5%. They're lending you money at 3.5%. Go to TD that might lend it to you for 3%. So the last question. True or false? Higher interest is always bad. So who says true? Higher interest is always bad. Who says false? Higher interest is not always bad. Okay, why?
Depends on whether you're receiving money from the bank or you're paying someone.
Excellent. So if you take a look at this right here, increased principal, lower principal, longer term, shorter term, higher interest rate, lower interest rate. So that is I set this up purposely like this. And why is that? Because in this example right here, Daniel was earning interest. He was putting money in a savings account and earning interest. So he wants these. In this case, Jeff is paying the bank money. And so it's he wants these things lower because he's paying. So false. All right. Depends if you are receiving interest, so like a savings account, or paying interest as in having a loan. Okay. And as I said, this is realistic. In reality, you will see these type of questions on EQAO. Okay. Homework will be page 33 and 34, where we compare the interest. Page 33, 34. Okay.